We want to find the limit of these very complicated rational functions. Numerator will have square root minus square root. Denominator will have cubic root minus cubic root. So 0 is not in the domain of this function, right? Because if we plug in 0 for x, we get a 0 in the denominator. So what do we do? So one thing we could apply is the famous Taylor's formula or Taylor's approximation. Well, let's call it Taylor's formula. Okay. Well, if we do that, you see this one is a square root of something, right? So the first one would be f of 0, thinking this as a function, right? Thinking as f of x. Then at 0, f of 0 would be 1. So let me keep writing limit x approaches 0. So the first term will be 1. The second term will have to take a derivative, then multiply by x minus 0. So if we do that, I'm going to skip the calculations. So we get x divided by 2. So similarly, if we do square root of 1 minus x, the first term will be 1. The second term will be x over 2. If you want to take quadratic, because I'm only end up with a linear, right? Then I can call the rest of the terms like a tail. So I'm only taking the linear form. So that's my numerator. So my denominator, I'm going to do the same thing. The only difference is a cubic root. So cubic root, if I use Taylor's approximation or Taylor's formula, I get a 1 plus x divided by 3. For cubic root of 1 plus x. Then for cubic root of 1 minus x, I get a 1 minus x divided by 3. Then, of course, I need to, add all the tails. Now, let's simplify a little bit. So the numerator have 1 minus 1, that becomes 0. Then x over 2 minus a negative, that becomes plus. So x divided by 2 times 2, I will get x. Keep writing limit. Get x in the numerator. Just ignore the tails. Then the denominator have 1 minus 1, 0. I have x divided by 3 minus a negative x divided by 3. So I get a 2x over 3. Well, what's the limit? X cancel with x. I get a 1 over 2 over 3, which is just 3 over 2. So the fantastic Taylor's formula can be used in many places. So this is the one way we can use it.